Hello everyone, so welcome back again, and today we are going to discuss about the neighborship or peering in between the different autonomous system number in BGP, right? And we will create the neighborship on the behalf of loopback IP addresses. So we have loopback IP address on R1, that is 10.0.1.1, and loopback IP address on R2, that is 10.0.2.1. So now we are going to create the neighborship in between the two routers by the help of EBGP. What? EBGP. So basically there is a problem with the EBGP neighborship. That is what the TTL value, the time to live value for the BGP is 1. That is means if I will create the neighborship in between R1 and R2 with the help of loopback, so there will be two hop count. How many hop count are there? This is first hop count 200.0.0.2, and after that it will count 10.0.2.1 as the second hop count. So to create the neighborship in between the loopback, the TTL value must be 2. So let's see what is the TTL value by default with the BGP. What is the BGP default TTL value? So first of all, I'm going to configure the BGP in between these two routers to demonstrate you what is the TTL value of the BGP. Okay. After that, we will create the neighborship or peering in between the R1 and R2 by the help of loopback by increasing the TTL value from 1 to 2. Okay, so now let's start doing the configuration in between R1, R3 and R4. Will observe what are the TTL value. Okay, so let's start with R3. So configuring terminal, sorry, so router BGP, that is 100. So AS is 100 over R3. Neighbor is what? 201.0.0.2. So for now, I'm creating the neighborship on the behalf of physical interfaces in between R3 and R4, and we'll see what is the TTL value of BGP by default. Okay. So here 200.0.0.2 and and remote AS is 200. Okay, now advertise the network in between them, that is 201.0.0.0, and mask is 255.255.255.0. So when I will configure the BGP over here, and I will go to the Wireshark in between router 3 and router 4, we got the TCP message over here. So TCP message will be available, and what is the meaning of this destination port number, that is 179. The 179 destination number belong to the BGP. So that is means this packet is forwarded by the BGP protocol, and if I will observe this packet, basically in this packet I will find that the time to live value is equal to 1. What is the TTL value? On this packet I have seen the time to live value for the BGP is 1. Okay, TTL is equal to 1. That is means if there will be next hop on the next router, then it will be unreachable. Okay, so now we are going to provide the reachability as well as we are going to extend this time to live value. So before that, let me also configure on R4 the BGP. Okay, so let's go to router number 4 and create the neighborship. Okay, so router BGP, that is 200, and neighbor is what? 201.0.0.1, and remote AS is 100, and network in between them is 201.0.0.0, and mask is 255.255.255. So we got the neighborship message in between the routers. This is the BGP neighborship message, that is means adjacency is up now in between R3 and R4. Now let's go to Wireshark and observe the packet. So we got lots of messages over here. So open message is generally forwarded to initiate the neighborship. Likewise, in OSPF, we have seen the hello message. So in BGP, there is no hello message, but an open message will be forwarded, and it will be only forwarded once. As we have seen, the hello messages in OSPF are continuous. After every 10 second, hello message will be forwarded. Before neighborship, hello message was forwarded in OSPF to create neighborship, to find the OSPF neighbor, and after that the hello message will be forwarded to maintain neighborship. But in case of BGP, the scenario is different. The OSPF will be forwarded once. After that, to maintain the neighborship, in every 60 second, the TCP message will keep alive message will be forwarded. Which one? Keep alive message will be forwarded. So as we can see, after each 60 seconds, the keep alive message will be forwarded to maintain the neighborship of BGP. If I will observe this open message, in this open message we can see that the TTL value is 1. So everywhere we can see the TTL value is 1. That is why, that is means the BGP can reach up to one hop. A single hop is only available. If I will observe the keep alive, here is also TTL value is 1. And in case of update message, still the TTL value is 1. Okay. Now let's move forward to the neighborship in between R1 and R2. So because of that, the neighborship in between the loopback will be unreachable, because this 10.0.2.1 will be count in second hop. First hop is what? 10 200.0.0.2, and that will be second hop. That is means it's not easy to create the neighborship in between these two. Okay. Now let's start doing the configuration in between R1 and R2, and we'll observe which packets will be forwarded and what will be the TTL value. So as we can see that the neighborship is easy in between R3 and R4, because we are creating the neighborship on the behalf of next hop. But in case of R1 and R2, we are creating the neighborship on the behalf of loopback, that is in second hop actually. So now let's start doing the configuration in between R1 and R2. So router BGP, that is 100, and neighbor, I'm going to create the neighborship in between R1 and R2 on the behalf of this loopback. So I will mention this loopback in the neighborship, that is 10.0.2.1, remote AS is 200. Also, I will mention the source IP address as our loopback IP address. So this information must also be provided over here, that the source is a loopback IP. So because we are creating the neighborship in between loopback to loopback, so let's mention the neighborship as the loopback IP address. So neighbor 10.0.2.1 update source as loopback 1. Okay, that's it. Now let's advertise the networks in between them. 10.0.1.1, 1.0, and mask is 255.255.255.0. Okay, another network is 200.0.0.0, and mask is 255.255.255.0. But dear, the point is that there is no TCP message, no BGP message in between these two routers. We are capturing the packet. We cannot see any single message, especially forward for the BGP. No BGP message, because the next hope, or the hope to create the neighborship is unreachable, that is belong to second hope. So we are going to change the next hope behavior. So before changing the next hope behavior, let's me also configure the BGP on router number 2. Okay, so let's go to router number 2 and configure the BGP. So router BGP, that is 200, neighbor is what? 10.0.1.1, remote AS is 100, neighbor, that is 10.0.1.1, and update source as loopback 1. Okay, and network in between them is 200.0.0.0 and mask is 255.255.255.0. Network is what? 10.0.2.0 and mask is 255.255.255.0. Okay, so still we have done the configuration of BGP on the behalf of loopback address, but still you will not find a single message in between these regarding the BGP. So there is no BGP message. Now, what we will do in this type of problem, let me extend the TTL value from 0 to from 1 to 2. How we can extend the TTL value? So router BGP, that is 100, neighbor is what? 10.0.2.1 and EBGP multi-hop as 2. So dear, I am mentioning the multi-hop as 2 because my loopback address is up to second hop, to the second hop. Basically, if I will not mention here the number of next hop, then it will automatically take the 255 as the next hop address. Okay. Now, whenever I will enter, so it will automatically extend the multi-hop address up to 2. That is means TTL value has now changed to 2, but still we are not finding any message for the BGP. Okay, let's do the configuration on right side also on R2. Okay, so router BGP, that is 200, neighbor, that is 10.0.1.1, and remote AS is sorry, update source as loopback 1. Okay, still we will not find a single packet over here. So what is the problem in between these? The problem is reachability. So there is lack of reachability in between this loopback and this loopback. So how we can provide the reachability? We have multiple options to provide the reachability. Like we can provide the reachability by the help of dynamic route. In dynamic route we can do the configuration of what? uh, OSPF, okay, EIGRP or RIP protocol. But dear, if I talk about these three, so these three protocol basically used in the IGP. So I'm not going to do the configuration of OSPF, EIGRP or RIP, and strictly OSPF is or EIGRP can be used with the IGP. These are the IGP protocols, so I cannot use for the external network. So what I will do in this type of scenario, I'm going to use the static route to create the neighborship in between R1 and R2. Let's create the neighborship in between R1 and R2 with the help of let's provide the reachability by the help of static route in between R1 and R2. Let's go on R1. So IP route, that is 10.0.2.1 2.0. Okay, subnet mask is 255.255.25.5.0 and next hop address is what? Next hop address is 200.0.0.2. Okay, so we have just done the configuration of static route over here. Let's see, is there any change here? So we got ARP message, that is means, and after the ARP, first one, router one is going to initiate the neighborship, right or not? And TCP message will be forwarded. If I will observe this TCP message, in this TCP message, after providing the command EBGP multi-hop to 2, we can see that the time to live has been changed from 1 to 2 now, right or not? Now the BGP is reachable up to 2 hop from the source, right? 2 hop from the source. Now TTL value is become 2. Okay, but still we we can't see any open message here because open message will be forwarded once we will advertise the once we will also change the TTL value on R2 because we are going to create the neighborship in between the loopbacks. Okay, so on R2 let's also extend the TTL value to 2. Okay, so let's provide the reachability on R2. How we can provide the reachability in between R1 and R2? IP route, that is 10.0.1.0, okay, and 255.255.255.0, and the next hop address is 200.0.0.1. Okay, once I will do this configuration, the reachability will be provided, and we got the EBGP neighborship in between the loopback IPs. We got the EBGP messages now, and we will see lots of messages will be forwarded in between these two. Okay, so there are lots of messages will be forwarded. If I will click on open message here, we can see that the time to live value is 2. Not only on this one, but in all the packets, the time to live will be changed to 2. Okay, let me observe on second one also. On keep alive or update message, everywhere the TTL value become 2. Okay, that is means now the destination address is also big. Source is 10.0.0.1 and destination is 10.0.2.1. Okay, let me try to ping them via source or destination. If I will go to router 1 and try to ping these, so ping 10.0.2.1 via source that is 10.0.1.1, so they are pinging perfectly. Okay, so by extending the TTL value after providing the reachability, the routers can able to forward the data. And let's go to router 1 and check the BGP table by the command show IP BGP. Here you can see that the next hop will be changed. Okay, 10.0.2.1 for all other networks. Okay, so this is how we can configure the neighborship by the help of loopback addresses. Dear all, if you have any confusion, please ask me in comments and have a nice day.